Hey guys, today we're looking at properties of logs and how we can use those properties to help us to simplify some of our logarithmic expressions. So here are a few of our properties that we will use. So the product property tells us that if we have log of u times v base b, we can separate out those two things and we end up with log of u base b plus log of v base b. Similarly, the quotient property will work so that we can separate out that u and v, but since we're dividing, we have log of u base b minus log of v base b. And these should look very similar to our exponentials properties because logs and exponents are very much from that same family. So then your power property is probably a new one for you. One thing we can do with that exponent, if we have that u to the nth power, we can take the n out front and multiply by the log of u base b, and then there's no more exponent there. That will help us in simplifying a few things. So, using our property, we see that exponent there. That tells us we can just bring it right out front and write this as 4 log of 3 base 2. Here we have the natural log of 1 over e to the third. We know that our base for natural log is e, so we don't have to write it, but I can write this as the natural log of 1 minus the natural log of e to the third. So now I have that 3 that I can bring out here. So I have the natural log of 1 minus 3 natural log of e. Now this is where our simplifying really works out for us because the natural log of 1, the log of 1, anything with that 1 is just 0 minus, and then I have 3 times. Now I have the natural log of e, so that's a log base e. Anytime I have the same base there, that just cancels in as 1. So now I have 3 times 1, or just 3. So 0 minus 3 is negative 3. So all of that simplified down to negative 3. Alright, another thing you're going to see is log approximations. And these are used a lot before calculators were prevalent and we could plug into calculators. So this is telling us if the log of 5 base 9 is about 0.732 and the log of 11 base 9 is about 1.091, find these things. So we want to try to get to the log of 5 base 9 and the log of 11 base 9 and separate those out so we can plug in those approximate values. So for this first one, since I have that division sign there, I know that I can separate these out using subtraction. And I notice then once I've done that, I have those things that can be approximated. So I have 0.732 minus 1.091. So that would be about negative 0.359. Alright, this next one, I have the log of 55 base 9. Well, 55 isn't anything that we know, but it is 5 times 11. So then if I have that multiplication, I can do the same thing I just did, except I'm going to have a plus sign here. So then I have 0.732 plus 1.091. and that's approximately 1.823. Alright, and then this last one, I have 25, which isn't something I know from our values that we've been given, but I know that 25 is the same as 5 squared. So remember, I can take that 2 and bring it out front, so I have 2 times the log of 5 base 9. So then I have 2 times 0.732, and I get 1.464, and that should be an approximate. Now I want to show you why this power works, so we can pull it out front. So if you look, we also could write that 25 as the log of 5 times 5, right? So then you would have the log of 5 base 9 plus the log of 5 base 9, which also would be 2 times the log of 5 base 9. It would give you that same value. So that's another way to look at why that exponential works, to pull that out front and multiply. Alright, so sometimes it'll just ask us to expand log expressions, which seems a little counterintuitive. It kind of seems like you're making the problem bigger, but that expanding sometimes helps us to simplify. So when we do this, we're going to keep the same base. We're always going to keep that log base 5 on A. So with this log base 5, I have 2 things that are multiplied. I have 2 times x to the 6. So I'm going to do the log of 2 base 5 plus, and then I'm going to do log of x to the 6 base 5, but I know that x to the 6, I can pull that 6 out front. So I'm going to go ahead and do that. If you want to do that in multiple steps, you are welcome to. Alright, and then this next one, I have this 6th power that is 2 to the 6th and x to the 6th. I have to distribute that 6th power to both, whereas the first one we did was 2 and then times x to the 6th. This parentheses tells me that both of those get a 6. So I would have to put the 6 out front on both of these. So they're slightly different because of the parentheses. Alright, this next one, I know that this is the same, this numerator is the same as x to the 2/3 power. So I'm going to go ahead and put 2/3 out front of this natural log of x, and then I'm going to subtract the natural log of 3. And I'm also going to subtract 3 times the natural log of y. And the reason I'm subtracting both of those is because we want to divide both of these things. If I put a plus sign there on the 3 natural log of y, it would look like it was up top as well. And so since you're dividing both of those things, you're subtracting the natural log of 3, you're subtracting that y to the 3rd, the natural log of y to the 3rd as well. So that's why it looks like that, to show that it's on the bottom as well. So condensing log expressions is the opposite of what we just did when we expanded log expressions. So logs have to have the same base and no coefficients. So we're going to have to move all those coefficients back up into the exponent before we can condense these back to one log expression. So this first one then, I need to rewrite as log of 7 squared base 3 minus log of x to the 5th base 3. They're both log base 3. Our goal is to get back to one log base 3. So since I'm subtracting, I'm dividing. So I have a log base 3. I have 7 squared, or 49, is my numerator, and then I have x to the 5th is my denominator. The biggest mistake I see is that a lot of students will try to leave multiple log base 3's in there. You're condensing back to just one. All right, this next one, we have this 2 out front, which tells me it's got to go into the exponent. So when I combine these two inside the parentheses, I have 15 over 5, and then I have a squared up here. Then I'm going to go ahead, this 1/2 out front, 1/25 to the 1/2 power means the square root of 1/25. So then I have 15 divided by 5, which is 3, and 3 squared is 9. So I have log of 9 base 6, and then plus the square root of 1 over 25 is 1 over 5. So log of 1 over 5 base 6. They both have a base 6, so that means that I can multiply. So 9 times 1/5, I'm going to have my log base 6 here. I have 9 over 5 as my answer when I combine those. 9 times 1/5 is 9/5. Okay, in our previous notes when I said, hey, we're going to skip over our graphing calculator piece here, this is why. We're going to get to graphing calculator next. So the change of base formula is something that some of you will need to be able to type in your graphing calculator. Some of you won't need this, but you still need to know how to do this to solve some problems. So it says if u, b, and c are positive numbers with b and c not equaling 1. If we have this log function, we can split it out and change the base to anything we want. So what it does is take the u, and it's the top part of that fraction, and the c is in the bottom part of that fraction when they were originally right here. C was our original base. So, and the reason this is necessary is because our graphing calculators will only do log base 10 or natural log. So if it tells you to find this answer in your graphing calculator, most of you won't just be able to type that in. You will have to use change of base so that you can make that log base 10 or natural log. So we will take, it says our u here is 8 in this case, and I'm going to use log base 10 so I don't have to write a base. And so I just have 8 over my log base 10 again, and then my original base, my c, now is in the bottom. So log of 8 divided by log of 4. Now you can type that in your calculator and get an answer. You also could use natural log, and it would look exactly the same. Natural log of 8, natural log of 4. If for some reason you wanted to do log base 52, I have no idea why you would use that. But anything will work. That's how it works. These two are the ones that you will use the most to type in your calculator, is the log base 10 and natural log. So that being said, this graphing calculator activity asks us to type in this to our graphing calculator. Well, we're going to have to use change of base to do that. So to type this in, we would have to put log of x minus 3 as our numerator and log of 2 as our denominator, and then we would add 1. From there, it's just going to ask you to plug into your table, plot some points. I think you guys can do this. You have done this many, many times. with different values. If you need me to go over this at all, let me know. I'm happy to. Otherwise, if you have questions on anything else, come in and see me. And if not, I'll see you in class.